Imagine a world so distant, so alien, that reaching it seems like an impossible feat. A place where ice-covered moons harbor oceans that might contain more water than all of Earth's seas combined, yet are buried deep beneath layers of ice, surrounded by radiation so intense that no ordinary spacecraft could survive. This is not science fiction, but a reality we're about to embark on with one of the most ambitious space missions ever conceived, the Jupiter Icy Moons Explorer. Jupiter Icy Moons Explorer is humanity's boldest attempt to explore the outer limits of our solar system, and it's about to take us to the frozen moons of Jupiter, moons that might hold the secrets to some of the most important questions in science today. The enormous challenge of reaching Jupiter. At first glance, sending a spacecraft to Jupiter's moons might seem like a wild dream. After all, the planet is a colossal 588 million kilometers away from Earth. That's 7,700 round trips to the moon. But the reason why we're willing to take such an enormous risk is tied to the extraordinary potential of Jupiter's moons, particularly Ganymede, Europa, and Callisto. These moons are unlike any other in our solar system, with vast frozen oceans buried under their icy surfaces. And beneath that ice, scientists believe there's a real possibility of life. However, getting to Jupiter is not just a matter of space travel. It's about surviving one of the harshest environments humanity has ever tried to explore. Jupiter's enormous magnetic field traps charged particles, creating deadly radiation belts that could fry any electronics in mere minutes. To put it simply, this mission is as much about the journey as it is about the destination. But Jupiter Icy Moons Explorer is not just any spacecraft. This is humanity's most advanced planetary explorer, designed to survive where no spacecraft has before. Jupiter Icy Moons Explorer. The Jupiter Icy Moons Explorer is the result of over a decade of planning, designing, and overcoming obstacles. In 2012, engineers at the European Space Agency began the intricate task of building Jupiter Icy Moons Explorer, knowing full well that it wasn't just about getting to Jupiter, it was about surviving its extreme conditions. After countless challenges and years of development, the spacecraft was launched in April 2023. The goal: to travel more than 7 billion kilometers to Jupiter using gravity assists from Earth and Venus to speed up the journey and adjust its trajectory. And this is just the beginning. Once Jupiter Icy Moons Explorer arrives at Jupiter in 2031, it will continue its journey for another 3.5 years, using Jupiter's gravity to navigate from moon to moon, studying the icy giants and collecting invaluable data. Crafting a spacecraft to survive Jupiter. Building a spacecraft to withstand the challenges of space travel is no easy task, but making one that can survive Jupiter's environment is a completely different ballgame. The spacecraft had to be designed from scratch, thinking of everything from radiation shielding to power generation, all while ensuring it would survive the intense cold and gravitational forces at play. Engineers had to think about every detail, down to the materials used, the systems on board, and how it would cope with the environment on Jupiter's moons. Communication, talking across the vastness of space. Let's talk about communication. Jupiter Icy Moons Explorer will be more than 588 million kilometers away from Earth, which means that communicating with it is no simple feat. A simple message to Jupiter Icy Moons Explorer will take nearly an hour to reach Earth. How do you manage that? The spacecraft is equipped with a massive 2.5 meter high gain antenna designed to transmit data at a rate of 2 gigabits per day under optimal conditions. While it's not exactly the speed we're used to with our home Wi-Fi, this setup is more than capable of sending critical scientific data and even images from the far reaches of the solar system. Solar panels for the outer solar system. Jupiter is far from the sun, and the sunlight there is about 27 times weaker than what we experience on Earth. So how do you power a spacecraft when sunlight is so faint? Jupiter Icy Moons. Explorer's engineers had to get creative. They designed special solar panels using triple stacked cells made of materials tough enough to withstand extreme cold and high radiation. The result, a spacecraft that can generate enough power to keep all its systems running, even in the dim, distant reaches of the solar system. But that's not all. Jupiter Icy Moons Explorer carries the largest solar panels ever sent to the outer solar system, spanning 85 square meters. These panels are designed to capture as much sunlight as possible, ensuring that Jupiter Icy Moons Explorer has the power it needs to operate its instruments and navigate the icy moons. It's a testament to the ingenuity of the engineers who made this mission possible, navigating the gravitational ballet of Jupiter's moons. Now, let's talk about navigation. Jupiter's immense gravity, combined with the gravitational forces of its moons, creates a dynamic environment that Jupiter Icy Moons Explorer has to navigate with pinpoint precision. It's not just about avoiding collisions. Jupiter Icy Moons Explorer must also use these forces to adjust its trajectory and conserve its precious fuel. In other words, Jupiter Icy Moons Explorer is surfing Jupiter's gravity field, hopping from moon to moon like a surfer catching the perfect wave dot. But this isn't just a matter of flying straight through space. Navigating through Jupiter's moons is like steering a drone through a storm of massive, ever-changing forces. To accomplish this, Jupiter Icy Moons Explorer relies on a sophisticated propulsion system capable of making ultra-precise adjustments. The spacecraft can make minute changes to its trajectory, ensuring it stays on course and doesn't waste precious fuel. Scientific tools for the icy frontier. All the engineering in the world wouldn't matter if Jupiter Icy Moons Explorer couldn't gather the data it's designed to collect. That's where the spacecraft's scientific instruments come in. These tools are the real stars of the mission, providing insights into the moon's compositions, magnetic fields, and potential for harboring life beneath the ice dots. For instance, the radar for icy moons. Exploration is a 16-meter antenna designed to peer through kilometers of ice to detect the ocean beneath. But developing this radar wasn't without its challenges. A tiny pin, barely visible to the naked eye, prevented the antenna from deploying correctly. The solution? Engineers created a giant origami structure to deploy the antenna in zero gravity. When the spacecraft used sunlight to warm the pin, the antenna unfolded without getting tangled, allowing Jupiter Icy Moons Explorer to continue on its mission, overcoming setbacks and finding solutions. Building instruments for space exploration is not for the faint of heart. Every single device had to be tested and retested, with engineers facing numerous challenges along the way. Take the Gala laser altimeter, for example. It's designed to measure the shape and elevation of Ganymede's icy surface with incredible precision, but temperature swings in space created alignment issues, which could distort the measurements. So engineers had to fine-tune both the hardware and software to ensure that everything stayed perfectly aligned. Then there's the Magnetometer, which will help scientists study Ganymede's unique magnetic field. By analyzing the variations in the magnetic field, JMAG will provide clues about the presence of a hidden ocean beneath the surface. And that's just one of the many instruments on board Jupiter Icy Moons Explorer, each with its own set of challenges and innovations. What's next for Jupiter Icy Moons Explorer? By the time Jupiter Icy Moons Explorer reaches Jupiter in 2031, it will have traveled over 7 billion kilometers. The spacecraft will use gravity assists from Earth, Venus, and other moons to adjust its trajectory, picking up speed along the way. It's a journey that's been years in the making, and the stakes couldn't be higher. Once it reaches Jupiter, Jupiter Icy Moons Explorer will begin a 3.5-year exploration of the Jovian system, studying the moons, their icy surfaces, and the potential for life beneath the ice. Jupiter Icy Moons. Explorer's ultimate goal is to reach Ganymede, where it will become the first spacecraft to orbit a moon other than Earth's. By the time this mission is complete, Jupiter Icy Moons Explorer will have transformed our understanding of Jupiter's moons and their potential to support life. If Jupiter Icy Moons Explorer confirms the existence of vast oceans on these moons, it will open up entirely new possibilities for life in our solar system and beyond. If you're as pumped as we are about Jupiter Icy Moons Explorer's incredible journey to Jupiter's moons, smash that like button and make sure to subscribe for more epic space exploration content. We want to hear your thoughts. Drop them in the comments below and let's keep the conversation going. Your support means the galaxy to us. Thanks for watching and stay tuned for more mind-blowing discoveries. Until next time, keep reaching for the stars.